Hello everyone. So far we have seen binomial distribution, Poisson distribution. These two are discrete version, and in continuous version we have seen exponential, and now one more continuous distribution, that is normal distribution. So we have four distribution in the syllabus: binomial, Poisson, both are discrete, and exponential, normal, both are continuous. So this is a continuous probability distribution having the probability density function. They've given the function as 1 by sigma root 2 pi e power minus of x minus mu the whole square divided by 2 sigma square. Here the condition is same. Each probability value should be greater than 0 and their summation should be equal to 1. Okay. So now in these type of problem, every time we are not going to integrate here like how we did in exponential. We will standardize this by substituting z is equal to x minus mu by sigma. And if you see this, this is nothing but the area under the curve. The total area under the curve is 1. And this is a bell shaped curve, and x is equal to mu is the middle point of the curve. So if you see that the total area is 1, and if x is equal to mu is the middle point, automatically this side is 0.5 and this side is, each side is 0.5. And if you see the area covered from minus sigma to sigma, area covered is 68%, minus 2 sigma to 2 sigma 95.44% area covered, minus 3 sigma to 3 sigma 99.43% area covered. So now we'll see mean and standard deviation of normal distribution. Yes, if you see the mean proof in the previous one, mean formula is same, x into f of x. In discrete we'll write summation. In continuous, minus infinity to infinity, x into f of x. So minus infinity to infinity, x I have written in the numerator. F of x, we had the formula, right? 1 by sigma root 2 pi e power minus of x minus mu the whole square divided by 2 sigma square. Okay. Now we are going to substitute the value because e power minus of a big chunk is there. So it's easy if we write e power minus t square. Correct? So our aim is to substitute this as t, so that I will write it as t square. So since square is there, x minus mu by root 2 sigma, I'll take it as t. Then I will get e power minus t square, and we know the value of e power. When we integrate e power minus t square, we know the value. So our aim is to make it as e power t square, and we want the negative sign also. So t is x minus mu by root 2 sigma, and then t into root 2 sigma is x minus mu. So minus mu, if it goes to the other side, it will become plus mu. So we got x. We can replace it here. And we want dx also, correct? So dx is root 2 sigma t if I differentiate dt. Mu is just a constant. So root 2 sigma dt is dx. So we got x, we got dx, we got t. Now whenever we change, use the substitution, we change the limit, right? So when x is infinity, again t is also infinity. When x is minus infinity, t is again minus infinity. So there is no problem in the limit. So I have written integral minus infinity to infinity, and x value is root 2 sigma t plus mu. We have written this e power minus t square, and then dx is root 2 sigma dt. We have written it completely. So in the denominator we had root 2 pi, no? So 1 root 2 and this root 2 will get cancelled. This sigma and this sigma will get cancelled, and we get 1 by root pi 2 sigma t into e power minus t square. We are going to split these two terms. Root 2 sigma t e power minus t square dt first term, plus mu e power minus t square as second term. So we are going to integrate this. Now this looks little hectic, but the thing is, if you see this function t e power minus t square, is this a function, even function or an odd function? It's an odd function, correct? We have solved problems in Fourier series by checking the nature. Either you can see the graph or replace t by minus t. You will get negative of the same function. So the function is odd. So if you integrate an odd function from minus a to a, the integral value is 0. So if you integrate an odd function minus infinity to infinity, the entire first function will become 0. So only we are having second function. All of a sudden it reduced 1 by root 2 pi minus infinity to infinity mu e power minus t square dt. Mu is just a constant, take that outside. E power minus t square is an even function, well and good. So minus infinity to infinity, we'll write it as 2 into integral 0 to infinity e power minus t square dt. And this value already we know, we have derived it. This is nothing but root pi by 2. You can take it as a formula. In the previous semester you might have solved this. So now we are taking it as a formula. So integral 0 to infinity e power minus t square dt value is root pi by 2. And this root pi and root pi will get cancelled. 2 and 2 will get cancelled. Mean of normal distribution is mu. That's it. Only two things you have to keep in mind. What is that? Proper substitution of t. And we want e power minus t square. Now you know. Why? We know integral 0 to infinity e power minus t square dt is root pi by 2. So that is why we made this as e power minus t square. So you have to remember the function, and just this substitution is correct means everything will go in place. So first term will become 0 since the function is odd. So this is a proof for mean of a normal distribution. Yes, now the proof for variance. This is almost similar to the mean. If you got the idea of mean proof, then this is easy. Only the formula is different. X minus mu the whole square, f of x dx. We know what is f of x. The whole junk I have substituted here. Okay. So same substitution, t as x minus mu by root 2 sigma. Therefore x minus mu is root 2 sigma t. Therefore dx is root 2 sigma dt. Same what we have done in mean. Same substitution. Limit is same. So I have substituted x minus mu as root 2 sigma t. Here since square is there, this will become 2 sigma square t square. Okay. And we have written the function f of x as it is. So e power minus t square. Because the whole thing, if you substitute this as t, you will get e power minus t square. This constant I have written as it is, and dx we know substituted this. Root 2 will get cancelled. Sigma will get cancelled. Only 1 by root pi will be here, and already here 2 sigma square is there. Take out all the constants outside and only keep only t terms inside, because we are integrating with respect to t. So e power minus t square into t square dt. Okay. So now this is an even function. So if it's an even function, you can write 2 into only 1 half. Correct? Why we have to do it like 2 into only 1 half? Because even function is going to be like similar function. For example, if you take like this is an even function. So instead of finding the whole area, only 1 half of the area, and if you multiply by 2, we will get a area of the total curve instead of finding from minus infinity to infinity. This is just an example. So in the same way, we are using the even function formula. So 2 into integral 0 to infinity t square e power minus t square dt. So now this value I am going to split t square as 1t I have written here, 1t I have written here, this 2 I have taken inside. 2t e power minus t square dt as dv. Why? Why we have splitting like this? Because if you integrate this term, listen carefully, if I integrate this 2t e power minus t square dt, what will happen? See here, integral of 2t e power minus t square dt. Put t square as s. So what you will get? 2t dt as ds. I didn't write t. 2t dt as ds. So 2t dt, everything I'll write it as ds e power minus s. E power minus es. Oh my goodness. E power minus s integration is minus e power minus s. So this is easy for integration. That is why we are splitting. So this t square, 1t I am keeping it here, another t is here. This 2 I have taken inside. So now we are going to apply, you can use integration by parts or Bernoulli's, both the way it is going to be the same, because we have only 2 terms here. So write the first function, even if you do it Bernoulli's, write the first function, integral of second function. We have written this. First is plus, second is minus Integral 0 to infinity. What is integral of this answer? Already we have calculated, minus e power minus t square. So I have written this. Okay. So in Bernoulli, already I have explained in the previous one. So plus, minus, plus, like that alternate signs will be there. So this integral answer already we know. So we have written it directly. That's it. And if you see what is this answer, it is minus e power minus t square. If I substitute it, already one t is there. So here minus e power minus t square. So upper limit e power minus infinity is 0. Lower limit, because of this t, it will become 0. So first term completely it will become 0. Here you cannot use that form that since it's an odd function, integral value is 0. Odd function in minus infinity to infinity only you can close your eyes and write 0. Here we have a value, but because of this limit, the first term is completely gone and we have only second term. So this minus and minus will become plus. So integral 0 to infinity e power minus t square dt. And this value is nothing but root pi by 2. Outside some constants are there. If you write down that constant, cancel it, you will get sigma square. Okay. So in this proof, what are the things you have to keep in mind? First thing is writing the formula properly. Substitution is the same. This is the first step. Second step, substitution. Third step, writing it as 2 into only 1 half. And the splitting, only this you have to keep this in mind. Why this is u, why this is dv. You can apply either integration by parts or Bernoulli's, you will get the same answer. So variance is sigma square. Mean is mu and variance is sigma square for normal distribution. And if you see the exam pattern, most of the times they will ask mean and variance proof for other distribution, and problems will be more in normal distribution. Problems in normal distribution are very, very important. Yes, only the derivation part in normal distribution will look little lengthy and tiring. The problems are very, very, very interesting because it's just going to be like a game or a puzzle. It's like because it's area under the curve. So just you have to write down the values and solve it. And don't worry about the big formula, that is f of x is equal to the whole big thing, because we'll be using only the standardized formula. Z is equal to x minus mu by sigma. This formula you have to memorize it for the problems. For proof only you'll be using this big f of x, because as I mentioned in the introduction, we standardize this and all the values, the integration values will be given in a form of tabular column like logarithm table. It will be given as a table. So even you might have studied numerical method for integration, same way. Here we won't integrate for each and every problem. They will integrate and they have given the values in table. So you have to just use the table only by using standardized substitution. That's it. So what is a new easy formula? Z is equal to x minus mu by sigma. Only you have to keep this in mind. Okay. So let's see the first problem. And I want everyone to be aware of basic concepts, because from here on the normal distribution problems pattern, the main important patterns I'm discussing here, you have to concentrate. If you miss this, then other problems you won't be able to understand. So please concentrate. Even I'm also feeling a little sleepy, but still it's okay. Okay, fine. See the problem. If x is a normal variate with mean 30 and standard deviation 5, find the probability of. Two things are given. So let's see the first one. P of 26 less than or equal to x less than or equal to 40. Now we are going to change x in terms of z. So z is equal to x minus mu by sigma. In the place of x we have 26 minus what is mean mu? 30. Sigma is 5. So 26 minus 30 by 5. Now once you have written 26 minus 30 by 5, instead of x what you have to write? Z. This is very, very, very important. Don't write x now. Okay. So second half, in the place of x we have 40 minus mu by sigma. 40 minus 30 by 5. So in each problem this will vary. Here in this problem they have given mean mu as 30 and standard deviation as 5. And if you calculate, this is minus 0.8. less than or equal to z less than or equal to 2. 40 minus 30 by 5, 10 by 5, that is 2. Okay. So now here comes the challenge. Listen carefully. It is just the area from minus 0.8 to 2. Correct? So in my graph I am plotting minus 0.8, 2. And if you see here, this is 0. Minus 0.8 to 0 I have marked in red. 0 to 2 I have marked in blue. So we want the total area for the problem. And now when I say area from 0 to minus 0.8, it is same as from 0 to 0.8. If we walk from here to a nearby garden, and if you measure the kilometers, and from the garden again to your house, it's going to be the same. So if we ask the distance, so from 0 to minus 0.8, the area is same as 0 to 0.8. So whenever negative term is coming, you just convert it to positive. So minus 0.8 to 2, the area, what I'll say, 0 to minus 0.8 plus 0 to 2. If I add these two, I'll get the total area. So 0 to minus 0.8 plus 0 to 2. Same thing we have written. 0 to minus 0.8 area is same as 0 to 0.8 area. So we have written in terms of positive sign. Because in table they will give only for positive values. Because there is no need, right? From 0 to 0.8 or 0 to minus 0.8, that doesn't mind. Only the area will be the same. So phi of 0.8 plus phi of 2. So this is the notation. Okay. So if I write phi of 0.8 means from 0 to 0.8. If I write phi of 2, from 0 to 2. And these values will be given in the table. So for 0.8 you have to see the corresponding value and you have to write it. In some problems they will give the value as it is in the question itself. And in the next class I'll teach you how to take the values from the tabular column. That's an easy one, same as log. Phi of 2 is this value, we are adding it. Okay. Hope you are able to get this. So your area is from minus 0.8 to 2. We are splitting this as 0 to minus 0.8 plus 0 to 2. So we got this. Yep, now the next question, p of x greater than or equal to 45. What is the first step? Change from x to z. So p of x to z greater than or equal to, what is the formula? X minus mu by sigma. 45 minus 30 by sigma is 5. Same problem we are continuing. So p of z greater than or equal to, this is 15 by 5. So p of z greater than or equal to 3. Now we are going to draw the graph. See here, greater than 3 means this area will come. Correct? Greater than 3 means completely this area. So how to find this? Because in tabular column everything will be given from 0 to particular. 0 to 3, 0 to 4, 0 to 5, like that will be there in the tabular column. Now I want the area 3 and above. For this, if you remember, I told total area is 1. Therefore only this side part, this is the middle part. So if total area is 1, the middle part from this side it is 0.5. That side is 0.5. So what I'll do, 0 to this side, total area from total, if I subtract 0 to 3, I'll get this. It is same as if I ask you how many marks you have lost in the exam. What you will do? Total minus marks gained. You will get the marks lost. Same way, total is 0.5 for one side, minus 0 to 3 will give you 3 and above. So from here, we are removing this. Imagine this as a piece of cake. I want only this part. So from the total, if I remove the 0 to 3, you will get this part of cake. That's it. So no need to memorize any formula, just draw the graph and use the logic. Because in some textbook, they will give it as a formula. Okay. So just draw the graph and use the logic. So 0.5 minus 0 to 3. 0 to 3, what is the notation? Phi of 3. 0.5 minus phi of 3 you can see in the tabular column and get the value, and this is the answer. And one more example. Mod x minus 30 greater than 5. Or you can see this also, p of mod x minus 30 less than or equal to 5. If you see this, modulus of x minus, so modulus of value means between the negative and the positive value. So I'll write minus 5 less than or equal to x minus 30 less than or equal to 5. Minus 30 goes to the other side. Minus 5 plus, it will become plus 30. Minus 5 plus 30, 25. Minus 30 goes to this side. 5 plus 30, 35. So they are asking you to find, in here it is in terms of x. Once it's in terms of x, what we have to do? Convert it to in terms of z. So what we will do? X minus mu by sigma. 25 minus 30 by 5 less than or equal to, now converted x to z. Please don't write x once you've substituted this formula. And this is 35 minus 30 by 5. For the same problem we are solving, that is why we were fixing mean, mu and standard deviation. So if you simplify this, minus 1 less than or equal to z less than or equal to 1. Can you please draw the graph for the same? Minus 1 to 1. Yes. And my graph is too bad here because I tried it by using left hand. Now if you have marked this correct, minus 1 to 1. So this is minus 1 area and this is 1. And from minus 1 to 1, I've given shaded the area in blue color. So this is the area. So instead of calculating from minus 1 to 1, it's same as 2 into 0 to 1. Correct? So minus 1 to 1 is same as 2 into p of 0 to 1. You got this? It's like if I calculate from here to the park you walk, and from the park again you walk back to your house and check the number of steps. So will you count in both the ways? No. From here to park, if you count, okay, 30 steps, and then you will write 30 into 2. Same way, minus 1 to 1, area is same as 2 into only 1 half, 0 to 1. So 2 into p of 0 to 1, what is the notation? Phi of 1. So phi of 1, you can see it in the table, write down the values. So this is your answer. So again, from minus something to plus something means it is same as 2 into only 1 half. This is the idea of the graph. Yes, we are near the end of the session. So directly I'm going to give in terms of z, because you know how to convert from x to z. It's simple, x minus mu by sigma. Once you have converted, let's see, here it's a converted problem. Minus 1.64, if you see here z I have written, it is not x, already it's in terms of z, to minus 0.88. What is that? Minus 1.64 to minus 0.88. Pause this for a second and try to draw the graph. Yes. This is middle part is 0. So this is minus 0.88. So this is minus 1.64. If it's not visible, wait, let me draw once again. Yes, now if you see that, same graph I've drawn here, 0 to minus 0.8. And then this is minus 1.64. Your area is, you have to find from minus 0.8 to minus 1.64. There is a small strip. This strip shouldn't be shaded because this is 0 to minus 0.8. I want the area from minus 0.8 to minus 1.64. Whenever I do, it's like something is a negative, you can convert it completely to positive side. How you can completely convert it? It is same as 0.8 to 1.64. It's on the left hand side, now it's on the right hand side. So if you see like this, it's easy for you. 0.8 to 1.64. If you do this, again, I want only this area from 0 to 1.64, only this piece of cake I want. From 0 to 1.64, if I remove 0 to 0.88, I will get this. Let me draw this graph again very clearly. Yes. Now if you see on the same graph I have drawn here, it is on the left hand side, now it's on the right hand side. So we are from 0.88 to 1.64 I want. So from 0 to 1.64, from the total, if I take this piece 0 to 0.8, I'll give the left, this in between. So it is nothing but from 0.8 to 1.64. So this value is same as phi of 1.64 minus phi of 0.88. So you don't write plus here. The idea is I want this piece of cake from 0 to 1.64. is nothing but phi of 1.64 minus 0 to zero point 0.8, that is phi of 0.88, will give you this value. That's it. And one more example, P of Z, now it's in terms of Z only, I didn't give in terms of X. Z greater than or equal to minus 1.96. Again, pause this for a second, try to draw the graph. Now, this is a graph. What you will do normally, you leave this part. You'll draw from minus 1.6 to 0. What is given? Greater than or equal to minus 1.96. So, till here to 0, from 0 to other side, everything is greater than minus 1.96. You will miss to include this area. So, what is the complete right hand side area? 0.5 plus 0 to minus 1.96. Correct? So, this right hand side is 0.5 plus 0 to minus 1.96. So, 0 to minus 1.96 is same as 0 to 1.96. So, directly we have written it is the area from 0 to 1.96. 0.5 plus. So, you got this. So, go through this video once again, and you can ask your doubts also in the Google Classroom. So, once if this concept is correct, we'll do more problems in normal distribution. What we have done is just a preliminary small example. That's it, just a warm up. So the main problems are yet to come. So before the next session, I want you to do one thing. Just draw a tabular column, write down probability of each distribution, mean and variance of each distribution, because we have so far studied 4 distribution. So in the next class, you'll be seeing normal distribution problems. For that, you have to understand these concepts, how we are taking the graph and the values. And these values, you don't worry. In the next class, I'll show you the table, or in the exam, they will give these values directly. Thank you. Have a great day.